We have seen R-type, I-type. Now let's look at S-type. We use S-type primarily to store the value into memory. The value is defined by RS2 and the address will be calculated from both RS1 and immediate value, and the operation is defined by function 3. Let's look at the details. To deal with memory, we have one more instruction called load instruction, but the load is of type I, only store is S-type, and both the instruction demands the immediate value 11 down to 0, 12 bits. In case of S-type, you need to understand this, the same immediate value 11 down to 0 actually placed at different locations. Look at this, that's the main difference, S-type. We use load instruction primarily to read the memory. We are going to read a particular location and then we are going to load the register, destination register with that particular value. So here the address is calculated from both RS1 and immediate value. So the address is always going to be RS1 plus immediate value. So here RS1 is nothing but base. Let's say base is 0, then it is going to be like 0 plus the offset defined by 11 down to 0. It's same for store operation. The address will be calculated from both RS1 and immediate value. But the difference is it involves RS2. RS2 has got the value. This is the value we are going to write it into memory. So we use store basically to write the value into memory, and we need the value. The value is available in RS2. The function defines the width of the operation. So we may want to write a word means 32 bits, or sometimes of word 16 bits, or sometimes only byte, that could be 8 bits. That's defined by function 3. If you consider load instruction, there could be different possibilities: load byte, load of word, load word, load byte unsigned, load of word unsigned, and store byte, store of word, and store word. And all these instructions defined by function 3. Alright, load and store instructions. We use load and store primarily to deal with memory. Sometimes we need to read the values from memory. Sometimes we want to write the values back into memory. So we use load to read the memory. We use store to write the values back into memory. Load is of I-type, store is of S-type. The address will always be calculated using both RS1 and sign extension of the immediate value. So we need to make the immediate value overall 12 bits into 32 bits because RS1 source register has 32 bits. So eventually the address is going to be 32 bits, RS1 plus sign extension of immediate value. When we say load, this is how you can visualize. The destination register will have the element of memory, and that's identified by the address, memory of this particular address. Address is nothing but RS1 plus sign extension of immediate value. When we say store, the memory is going to have the value RS2. So the data is available in RS2. This particular data we are trying to write back into memory, and the address is calculated from RS1 and immediate value. Memory of address equal to RS2. As we have seen, there are different possibilities. We can load byte, of word, word, byte unsigned, of word unsigned, or store byte, store of word, and store word. All these instructions defined by function 3, and this opcode indicates whether it's of type load instruction, whether it's of type store instruction.